Assalamualaikum and a good day. Today, we would like to share the case study which is related to the shaper mechanism. The shaper process is a method of removal of metal from a surface in horizontal, vertical, and angular planes using a single point cutting device stored in a RAM that involves interaction with the tool in a single direction across the workpiece held on the machine's table. At the end of the stroke, the work is fed in a small increments at right angles to the direction of the RAM. The design of the shaper should be fulfilling the mechanism in such a way that allows the RAM to be slower during its forward cutting stroke. The cutting speed varies depending on the material and machining condition, whereas the idle return time is constant. The slider moves quickly forward and removes material from the workpiece, whereas in the forward stroke, the slider moves faster than in the return stroke, resulting in a quicker return, also known as a return stroke.
For calculation, as we know, this equation already given WAB and the length of AB and BC. Okay, for this equation, we must find the WBC and velocity of C. Okay, firstly, we must find the value of velocity B using the angle 45 degree, and then we put in the formula and we consume the value of velocity C is 0, and we find the WBC. After we get the value of WBC, we continue with find the value of velocity of C. Okay, after we get the value WBC and velocity of C, we continue with the acceleration and magnitude of B.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ismail Salim bin Matsani, MA21053. Now I will show you how to solve our problem using GIM software. First of all, make sure the mode is in geometry mode. Then, to plot the point on the grid, we use new point. Then we can put our coordinate of the point in the box here. Then click OK. Put all the point here. Now you can see all the 3 points have been done. Then we choose chain of bars to connect all the points to be an element. Click on the point to connect them together. Now we have all them connect. Then we use revolute join to revolute all the point that we want to revolute. Click here. But for point C, we use sliding revolute join because it allows the movement of the joint C. Now, as you can see, our drawing is done. Next, we can proceed to the kinematics part. We click on the kinematics here. Then, to create the movement, we click on the rotation actuator and click on the element AB. Now, the software, as you can see, it generate the simulation and analysis for the movement automatically. Then as stated on the question, we need to change the velocity to 4 radian per second. As you can see, I have already changed it. So we can proceed. Now for more details, we can click on the result function button, click the result, and then it will automatically can show us the point and the element. So for the point, we can create either velocity or acceleration of the point. Then for example, this point C, the velocity for point C, then this the velocity for point B. Then we can, if you want to change it to the element, if you calculate the angular velocity and angular acceleration, then we choose element AB and element BC. Next, I will show you the kinematic graph that I've been generated from this GIM software. First, the velocity at point B is 1.199 meter per second. Next, the velocity at point C, the value is 1.696 meter per second. Then we move on to the acceleration. The acceleration at point B is 6.315 meter per second square. Then the acceleration for point C is 10.534 meter per second square. That's all from us. Thank you.